Welcome. In this video, we're going to learn how to find a critical value Z alpha over 2 using our calculator's ZInterval. All right, so the Z-score with a subscript alpha over 2, we're going to learn what that's all about. But first, just a Greek alphabet here. So alpha, we'll be looking at lowercase Greek alpha. So first letter of the Greek alphabet. All right, so let's see what this is all about. So when we find these critical values, they will be associated to a certain level of confidence in creating a confidence interval. So we're going to do an example of what if we were to create a 95% confidence interval, and we'd like to find this value Z alpha over 2. All right, so alpha. So alpha is the complement of the confidence level. So alpha will be 1 minus the confidence level, and we'll work in decimal here. So 1 minus 0.95 leaves me 0.05. So I will be working in decimal, but I wanted to just write that as a percent here. So just again, these are complements together, 95 and 5% would add up to 100%, or in decimal 1. All right, so let's look at the graph for a moment. So what we're doing here on our Z distribution, our standard normal distribution, is looking at the center of the graph. Most of the time, if you pick a Z-score, it's going to be here towards the center. And in particular, I would like that middle area to be 0.95. So 95% of the time, we're going to get a Z-score in this region. So when we subtracted 0.95 from 1, that's telling us what would be left over in these two tails together. So if 95% of the graph here is in this center part, that still leaves me 5% to get the entire area. All right, so these two sides together are 5%. So the reason we have alpha over 2 is we'd like to know how much area is in each tail separately. So working in decimal, alpha was 0.05 divided by 2. That will give me 0.025. So now what I know is that the area in this left tail is alpha over 2. And this area in the right tail is also alpha over 2. All right, so if we added those three areas together, we would have to get 1. Okay, so this notation. So when we have a subscript on a z-score, that subscript indicates the area to the right of the z-score. So it's called Z alpha over 2 because it's the z-score such that an area of alpha over 2 is to the right of it. So I'm just going to write here. So this is the area to the right of that z-score. And that's what we're trying to find, that z-score. Okay, so Z alpha over 2 in general, and let me give the specific value. Our alpha over 2 in this case is 0.025. All right, so that's the area to the right of that z-score. All right, so let's find that z-score using our calculator. So what we're going to do is hit your stat button. So I'm going to clear my screen, hit that stat button, and then arrow over to tests, and then look for ZInterval and hit enter. All right, so on this screen, what you want is input on stats. And then for sigma, we want 1. X bar, we want 0, and N, we want 1. So later, when we start doing application problems, we'll have different values that go here. What we're doing now is just using the Z-interval for the purposes of finding a Z-score, but later we use it to do applications. All right, C level stands for confidence level. You want 0.95 there. And then calculate. And you'll see it gives two z-scores, a negative and a positive. So on my graph here, this z-score to the left of 0 would be negative 1.96. And then that z-score that we were looking for, the critical value is the positive 1.96. So z subscript 0.025 is 1.96. So the z-score that's negative, it doesn't get its own notation. We would just call it the negative of the z alpha over 2 value. All right, so even as I'm saying all this out loud, it sounds like a lot of words, but z alpha over 2 is 1.96. So fancy notation here just to say that z-score separates the top of the graph from the rest, and that top area in this case is 0.025. All right, so you can use your z-interval to find the critical z values, but just to end here, we can also possibly just read answers from tables. So if you look at your t table, t distribution, we're doing z right now, not t, but the last row of the t table has z-scores. And we talk about why it says infinity later. Just know these are z-scores. So the confidence interval, we were doing 95% for the confidence level, and then you'll see 1.96. So oftentimes we can just read answers from tables as well. And then sometimes you might just get a list of common z-scores. So as long as you know how to read the notation here, we just did the z with an alpha over 2 of 0.025. So as long as you know your value for alpha over 2, then you could read the answer there as well. All right, I hope that helps a little bit in finding your critical z values.